Yeah. Yeah, because there's a lot of people that built those cabins out on the marsh. And guess what? When the tide comes up, they get wet. So
Yeah.
now they're getting wet more winter more often.
I mean, right?
Yeah, this is being part of PGI. So he's also on our sustainability.
You, what's up there, guy? How's- Perfect. And
I'm Lori, I'm a resident.
awesome, nice to meet
Nice to
you.
meet you.
Nice to see you here.
Thank you.
This company right there.
La La Land, well,
Out there on the ether.
I mean, I just doing a lot of my meetings through June, still on Zoom,
Yeah.
especially these volunteer committees, because the cost and expense and time of it going to a meeting.
Yep.
And then and so forth. So I'm going to poll them and find out if they want to continue doing the Zoom, which is unfortunate because there's no.
Surrounded, they wait for putting together a management plan, which of course I've got a little bit of involvement in the past. And we have not met since August of 2019. There's most of us scattered, rather than a couple of people, live in Colorado, and Texas.
Right.
Okay. Everybody can hear what you're saying
Okay,
right now. Okay.
I'll be quiet.
My microphone's tied into everything. Okay. All right. Welcome, everyone. Welcome to our sustainability information session. My name is Kelsey Mack. I'm the environmental specialist for the city of Cocoa Beach. I oversee the sustainability committee as well as do a number of other things. So if you have any environmental questions or sustainability questions, go ahead and reach out to me. I'd be happy to help you with that. Just a few housekeeping items before we get started tonight. If you are joining us virtually, thank you so much for being here. If you do have questions throughout the presentation, go ahead and put those in the chat box and I will read those aloud to our presenter at the end of his presentation. All participants online have been muted so that there is no disruption throughout the presentation. So please put those in the chat box. We do have more information sessions coming up. The next one is on June 23rd. Dr. Bonnie Wells from the University of Florida, IFAS, is going to be here talking to us about fertilizers and the impacts on the Indian River Lagoon, as well as what you can do in your yard to have a Florida-friendly lawn. In addition to that, on June 30th, we have Florida Power and Light will be here talking about their Solar Together program and how residents can get involved in that larger solar power effort. And lastly, the city just announced a fertilizer campaign. We want everyone to know that we have a city ordinance banning the use of fertilizers from June to September. So we're launching a flamingo decorating contest. We want the flamingo to be the symbol of a fertilizer-free lawn this summer. So visit cityofcocoabeach.com/flamingo to learn more about that campaign. You can take our fertilizer-free pledge for the summer and you can purchase flamingos there as well. So I have one of our little flamingos here this evening. This was painted by a local artist. This is part of the city's traveling flock. So we want to see who can paint the best flamingos, and first, second, and third place for each month, June through September, will take home prizes. So we have some really awesome things like some rain barrels, some native plants for your landscape. So it's a really awesome contest. So again, cityofcocobeach.com/flamingo. You'll learn some more information there. And lastly, I would like to welcome our presenter tonight. We have Dr. Randall Parkinson. Dr. Randall Parkinson is a coastal geologist who has studied and published on the effects of climate change and urbanization on the built and natural and human environment for nearly 40 years. He's the president of R.W. Parkinson Consulting, which is located in Melbourne, Florida, and an associate research professor at Florida International University's Sea Level Rise Solutions Center that's located down there in Miami. He was a member and chair of the Brevard County Environmentally Endangered Lands Program for 2 decades, and currently the chairman of the City of Melbourne Beautification and Energy Efficiency Board. Dr. Randall Parkinson has lived in Melbourne since 1987, so a Space Coast local. So I would like to welcome him up to the stage and go ahead and tell us a little bit more about sea level rise.
So thank you very much for that introduction. And yeah, I published my first paper on sea level rise in 1987. So 35 years ago or something like that. This has been something that's been on my mind. I also have an environmentally friendly lawn, all natives and no fertilizers. It's a great element of trying to improve water quality on the lagoon. So what Bob Day asked me to do was, whom I've known since about the same amount of time, 1987 or thereabouts, when you were with the Indian Lagoon National Estuary Program. And actually, Bob was instrumental in getting a grant from EPA to do an assessment of the vulnerability of the city of Satellite Beach back in 2009, which really launched Satellite Beach as a real leader in taking sea level rise seriously. And since then, of course, a lot of other municipalities have joined into that and really trying to plan for and prepare for what is inevitable. So first of all, what I thought I would do is just mention sort of global warming is the primary cause of sea level rise. And there are a number of factors that influence future sea level rise. And these are listed in an order of contribution or importance. The first is ice mass loss from West Antarctic and Greenland. These are continental glaciers, and they contribute about 52%, or let's just say more than half, of the water that used to be on a continent, but now it's going into the ocean. So it's analogous to turning on a spigot in the bathtub, right? It's new water, it causes sea level to rise. The second one, about 38%, is thermal expansion. So as the climate warms, the upper layers of the ocean warm as well, and they dilate or expand because warm things expand, cold things contract. So more than half is new water from continental glaciers. About 40% is from thermal expansion, and the balance, or about 10, is from like the melting of mountain glaciers, changes in ocean circulation, and changes in atmospheric pressure and so forth. But these are minor. So the two things that we are most concerned about and that we track that drive the signal is the melting of continental glaciers and thermal expansion of the ocean. Now, on top of that, there are other regional and local factors which can influence changes in sea level rise and the risk of coastal flooding. So the two big ones, continental melting and thermal expansion, they apply everywhere. That's new water or new elevation that goes everywhere. But locally, not everybody has the same rate of sea level rise, because there are regional and local factors which can aggravate the contribution at the global scale. So one of them is tectonic or isostatic land motion. So this is minimal in the Space Coast. These are areas where like on the west coast of California and the west coast of the United States, we got the San Andreas Fault, we got Mount St. Helens. It's an active plate boundary, and tectonics in that may cause it to uplift or downlift over time, and that modifies what you experience if you're in a town. So your sea level rise may not be the same as the global sea level rise because you have regional effects. Local hydrology, local subsidence. So again, minimal here on the Space Coast, but like down in the Mississippi River Delta, where there's 2 miles of sediment that has accumulated over the last 6,000 years, that's compressing by under its own weight. And so if you live along the coast of Louisiana, you are sinking. So the relative rise in sea level is a combination of the global contribution and the fact that you're sinking. Okay, and then there's some other minor ones, which we recognize, during heavy rainfall events, the Indian River Lagoon seems higher, right? That's sort of for a day or two, or during storm surge, we'll see some waters that'll build up for a day or two, or during tides, like the fall rise, also that we have here from November through the early part of January and February, where water levels are on average about a foot higher. And then we have the king tides, which occur as a consequence of astronomical. So not every place has experiencing the same sea level change over years, hours, days, you name it. But all municipalities can know what that is. In our case, along the East Central Florida coast, the primary driver is the global. We don't have any tectonism, we don't have any subsidence. So we essentially have the same signal as what is occurring because of the melting of continental glaciers and the thermal expansion. So here's an example of what I mean. So this is a map of the world, basically, although I guess Antarctica to the south isn't there, but these arrows represent rates of sea level rise, with the cool colors being falling sea level and the warm colors being rise. So for example, if you look up sort of in the Nordic areas, Scandinavia and so forth, sea level is actually falling. Why is that? Because that was covered by a mile of ice just 18,000 years ago. And that weight pushed the crust down. And since it's melted, the crust is rebounding. So sea level is falling because the land is rising. Relative sea level is rising. If you look down in the Gulf of Mexico, there's an arrow there. Let's see, right here. Hopefully you can see that right here. And that one is the biggest one in the continental United States. And that's because the Mississippi is there and it's subsiding. So the rate of sea level rise is the global plus the local. Here in Florida, ours is dominated simply by the global signal, which simplifies our ability to understand what it is and figure out what we're going to do about it. So this is a photograph down in Satellite Beach during a king tide, or so-called nuisance flooding now. But clearly, these drainage canals were not designed to be at capacity at high tide. So the fact of the matter is, this is real evidence that sea level is rising because the nuisance tides are just about to overflow a canal system that was built in the 60s. So that's the reason that it's almost flowing, is because sea level has been rising. And then on top of that, you have these local factors. So what is the cause of sea level rise? And is it always been happening? And it shouldn't be anything we worry about, as we hear quite a bit, or we used to. This is climate always changes. So this is a graph that shows 3 different parameters. On the top is temperature. So 0 is essentially what it is today. And along the horizontal axis from the very left is 400,000 years ago. and the very right today. So you can see that the temperature has risen and fallen relative to today's temperature for 400,000 years. Below that is CO2. And CO2 is measured in the Earth's atmosphere in parts per million. So you see CO2 parts per million. So at the beginning or very left, the amount is, say, 275 parts per million. You see it fall, you see it rise, you see it fall, you see it rise, and so forth. And finally, sea level, where 0 is today. So 400,000 years ago, sea level was about where it is today. And then by 350 years ago, it was 300 feet below where it is today. And it rose and fell. And the associations are, as you can see, I need to tell you, where do we get that information? So this information was derived from ice cores. So this is a drill rig in Antarctica, and they are drilling ice. And some of these are nearly a mile long. And they bring the ice up, and they take it out of the core barrel, and they look at it, and what you can see are bubbles in there, right? At every layer in that ice core used to be at the surface of the glacier, just like where that dude is standing. And the bubbles are what was ever in the atmosphere at the time that ice was accumulating. So these layers record in the bubbles the composition of the atmosphere, tiny bubbles. And they look into those bubbles and they measure things that, like the amount of CO2, proxies, radioisotopes, and so forth, to figure out the temperature, CO2 concentration, and so forth. So that's where that data came from. So what you can see is in the shaded vertical bars, there were periods when sea level was higher, and note the relationship. When CO2 is high, the temperature is high, and sea level is high. Why? CO2 is a greenhouse gas. So when there's a lot of CO2 in the atmosphere, the Earth warms because the radiation, the heat that comes from the sun passes through the Earth's atmosphere, but at a certain wavelength. And when it is re-radiated off the Earth, it's at a different wavelength, and it can't get through. And so it builds up. And as it builds up, the temperature warms. And as the temperature warms, ice starts melting and the oceans start expanding. So there are also periods of low stand. So 15,000 years ago, for example, sea level was 300 feet below present, right down here, right? And CO2 was relatively low and so forth. So rise and fall. So this is sort of where the argument came from that climate's always been changing, which is natural. Let's look at where we are now. The current CO2 level is 412 parts per million. The average over the last 400,000 years is like 350. I've been doing this for, what did I just say, 35 years. Every time I give a presentation, I have to check and change the slide because the amount of CO2 in the atmosphere is rising at about 3 parts per million per year. And I've been doing this for 30 years. That's 60. So when I started off, CO2 was 360 or thereabouts. And the temperature since the 1980s has risen 1 degree C, 1 degree Celsius. Now that's 2.5 degrees Fahrenheit, I think. Why do I say 1880? I guess you could also see here, look, there's where CO2 was, right here, right? And it has gone straight up to here, way beyond where it was over the last 400,000 years. And this is one of the arguments that this is human. And secondly, all this happened after the Industrial Revolution, where we started to use fossil fuels to create a new society and blow up in that regard, but there was a consequence that nobody knew about until the 1950s or thereabouts. So just some examples of what this has done as evidence that the Earth's climate is changing, but not only that, it's changing the Earth itself in terms of the environment. So what you see here is Canada, and the green areas in here are areas that used to be tundra or snowdrift, and their biota is actually changing, and their green plants are beginning to move in there that tolerate warmer conditions as the tundra melts and is replaced by plant communities that are more tolerant of warmer air temperatures. This is an example of where the size of the Arctic sea ice in 1980. You can see there 18 million square kilometers. What is that? In 2012, half. So why is that ice not there? It melted. Now, sea ice doesn't cause sea level rise because it's analogous to an ice cube in a drink. The level of your drink doesn't change as that ice melts because it's already displaced the volume that as it melts, it just never. But when that happens, there's less area that's bright white, meaning it's darker. So when the sun's rays come in, they're not reflected, they're absorbed. And that's a feedback. So now the ocean starts to warm because it's retaining that heat, and it's warming the area's land masses around it, such as northern Canada. This Rivers of Ice expedition, you can see here, these are the Himalayas, the top picture 1921, the bottom 2007. That's the exact same perspective. One of them has ice, one of them doesn't. Where's that water going? Into the ocean. Here is an example from Greenland. So there's a continent, right? The glacier is melting, and that water is going in, and like a bathtub faucet, it's filling in the world's oceans and causing sea level to rise. Another example, the thin blue line. This is carbon dioxide, which we know has been going up since we measured it, that blue line. This is the heat content of the surface of the ocean, and it tracks it perfectly. As CO2 rises, temperatures rise, the heat in the ocean rises, the ocean dilates or thermally expands. What does this all mean? Well, today, when I first started working on sea level rise in the early 80s, we used a number of 2.5 millimeters per year. And it seems like a small number, and it is. Today, it's 3.3. That's almost double. And you can see here on the horizontal axis is time towards the year 2100, which is a standard end date for which we need to think about and plan. And on the vertical axis is elevation in feet above present. And these lines are different scenarios that NOAA, the National Oceanographic and Atmospheric Association, has calculated, and they range from 1 foot to greater than 8 foot by the end of this century. And the difference between these projections is how much CO2 is in the atmosphere. Okay, and you can also see that the slope of the lines generally becomes steeper with time, which means that the rate of sea level rise can be expected to accelerate. Just as in when I began my career, it was 2.5, it's 3.3, but the acceleration is going to get faster and faster, meaning if you live along the coastline, it may be 1/10 of an inch now, but it could be an inch a year in the future. I mean, and that is, as you can imagine, that's significant in terms of how you plan for that and what impacts it has on your built-in natural environment. So what do we do about it? So this graph here shows the global temperature trends relative to average. So it's relative to pre-industrial. You see that number 1880 to 1810. So that's sort of where temperature was on the very, so the temperature zero would have been the temperature back then. And as that temperature increases on the vertical axis, that's how much different it is from just after the Industrial Revolution. And there's a straight line, which is sort of the linear trend in the actual measurements. So what do we see? By the year 2040, the temperature increase will be 1.5 degrees C larger than pre-industrial revolution, 1.5 degrees Celsius. That was the target of the Paris Climate Accord, which was signed about 2 years ago. Everybody says we've got to keep the temperature below 1.5. Well, we're going to miss that. We're already going to miss that. So when we go back and look at these projections, the lower two are all related to about that much CO2. So those are gone. Realistically, by the end of this century, we're looking at between 3 and greater than 8 feet. Again, dependent upon how much CO2 is in the Earth's atmosphere. In addition to just the risks associated with sea level rise, Florida and this community and all of us are especially susceptible because the elevations along the coastal zone are almost at sea level, right? So all that blue and magenta, that's basically at sea level. So it's not like we're sitting up in New Hampshire at 25 feet above sea level. We're at sea level. So these changes in sea level have an immediate impact, even at low rates or elevations. Also, all of the yellow, I'm colorblind, but I'm pretty sure that's yellow and gray. That's the near surface geology. That's all sand or limestone, like the Coquina or Anastasia or the Atlantic Coastal Ridge, which was, by the way, a shoreline during the last sea level high stand. So the water, as sea level rises, so does if you live on the island and you have a canal, and sea level rises, that rises with it. It's not like it's solid rock, and you certainly can't build a levee to protect from rise because the water's going under it. So we are especially vulnerable to the effects of sea level rise because of our low elevation and our geology. A final comment about where we're going, and I'm often referred to as Dr. Doom. I'm feeling a little bit better about everything now because communities like Cocoa Beach and others are beginning to take this seriously. There were decades when I would make these presentations and people would harass me. But now, what I want to show you here is it is increasingly unlikely a temperature increase by the end of this century can be limited to less than 2 degrees, as the emissions gap between the goal pledges and business as usual is not likely to be close. So what do we have here? Down here is time. This is the amount of emissions. So here we are going up. This is, I think, 2040. Can you see what that is? I think it was 2040. But here's where we are. In order to keep temperatures below 2 degrees, we would have to follow this curve. Reduce emissions to 0. This is what countries have pledged, which still gives us 6 degrees warmer than today. But this is really where we're at. Nobody's actually done any of this, which is telling us at the current trajectory, by 2100, the average temperature of the Earth's atmosphere will be 8 degrees warmer than today. And of course, that means more melting, more thermal expansion, and higher rates of sea level rise. So communities are doing something about it. I'm just putting down here the two that just completed their what are called peril of flood analyses funded by the Florida DEP's Resilient Coastline Program. One of them is from the city of Melbourne, and then the county of Brevard has actually done this as well, where they're beginning to evaluate what are their vulnerabilities to sea level rise. Also, increased storminess, because we know there'll be more intense hurricanes and more intense rainfall events. So all that contributes to more and more water. But communities are beginning to do something about this. Thankfully, so is finally the state of Florida. State of Florida has two very significant initiatives that acknowledge the threat to human life and quality of life, economic prosperity created by climate change. So the big one here I wanted to highlight was that there's a companion set of bills, House Bill 7019 and Senate Bill 1954. These will establish a Resilient Florida grant program within DEP to fund costs of community resilience planning. So right now, the Resilient Coastline has a couple of million. We're looking at the perhaps, billions that'll go into this over the period of time, but a serious commitment finally. It will require DEP to compile data to develop annual statewide flooding and sea level rise resilience plan. I have to tell you, I went to my optometrist and she said that these really aren't the kind of glasses I need. So I can't even read this hardly. I'm getting a new pair though. So this is significant. So the state is actually, instead of individual municipalities and collecting information, wherein each of them may have a different sea level rise scenario, or they may have different ways of looking, we're going to finally get a homogeneous methodology for collecting information and reporting it. This is huge. And finally, it authorizes local governments, water management districts, and flood control districts to annually submit proposed resilience projects to DEP and authorize DEP to rank and fund those subject to their annual appropriations. This is a big deal. And it's a significant turning point in the state of Florida's acknowledgement of a risk that we've known about for 40 years. Nonetheless, it's happened. There's another state initiative. This is called the SLIP rule. So this is a Florida Administrative Code Rule 62S-7, sea level impact projection, hence SLIP, studies for state finance coastal construction. The Department of Environmental Protection will require state finance contractors to assess the potential impacts of sea level rise and storms on new coastal construction. Big deal. So I think the evidence is clear that sea level rise is accelerating. Climate change is real. And many local municipalities have recognized this and have done something about it. But we finally have the state of Florida acknowledging the challenge ahead. And in the end, it's going to take more money than the state of Florida has to do. I mean, the big challenge is, even if we get all organized and we plan, the implementation is going to be mind-boggling on what this would cost. So we still have a lot of challenges, but we've made a lot of progress, especially over the last 5 years. With that, I would defer to you if there's, I don't know how you want to do this. If people have questions or something, be happy to answer. I tried to keep it reasonably short to provide time.
Okay, awesome. So thank you so much for that presentation. That was wonderful. For the folks joining us at home, we will take questions in the chat box. We'll be monitoring that and I'll read those aloud. Anyone in the room, if you have a question that you would like to ask, we'll have you come up to the podium here so that everyone at home can hear you through the microphone. So it doesn't look, I have a few here from the chat, but does anyone here in the room have any questions to start off? Come on up.
Am I still in the view? My head cut off.
We are all in the view.
Okay.
Thank you.
I don't watch, by the way.
Thank you for a great presentation. The two bills you mentioned in the House and the Senate, you didn't say, are they going to pass or are they an uphill battle or?
No,
or things?
no, my understanding is that when I last checked it, same with that slip rule. Slip rule, I know went without any, they published it on whatever, and it went unchallenged with detail. I know that's moving forward, and I'm, as far as I know, the Senate House bill, companion bills are, they have slightly different language, they're being reconciled, but that's moving forward.
So we don't need to call our representatives.
We should always do that.
Thank you.
Okay, we'll take one from the chat. Someone is asking what areas of Brevard County will be most impacted by sea level rise? I know you touched on this briefly, but you want to go over it again.
So it's not proximity to the ocean, it's elevation. So along the barrier island, the greatest changes that we'll see will be flooding from the Indian River Lagoon, Banana River, Mosquito Lagoon. Because of that porous geology, when sea level rises, it's going to raise the elevation of the Indian River Lagoon and all the water on top of it. Then any tributaries that come off of the lagoon and go into the mainland will rise as well. And lastly, the St. John's, where I drove out to give a talk the other day to the government center. I got lost. There's so much development out there. And if you look at the drainage canals, they're like 5 feet above sea level. So all those homes and all that, mark my word, are going to have serious problems with stormwater management and flooding. So those are the elevation and proximity to water, but it doesn't have to be the ocean.
Okay, very nice. The next question is, what can the folks at home do to help limit sea level rise?
So first of all, there is being knowledgeable, because we have to have the political will. So people have to inform themselves enough to where they can change the conversation. If the conversation is not science-based, that's a very important for just grassroots. Then as individuals, we have to deal with the greenhouse gases. So there's adaptation, where you just adapt to the rise. Maybe you build your roads higher or so on and so forth. But there's also mitigation, active participation. So reduce your carbon footprint, which means raise the temperature in your thermostat by 1 degree. You wouldn't believe the energy benefits that are a consequence of not keeping your home at 76 degrees C. 1 degree, I don't know the numbers, but it's mind-boggling. Our home is at 78. And in terms of fuel, obviously, plan your driving to where you are not driving every 10 minutes, but you try to organize, okay, I'm going to go do these 4 things at the same time. All of these have to do with the energy that is consumed when you air condition your house or you drive, and all that energy is producing CO2. And there are many others. It's a challenge in that you could make a long list, and for the most part, with the way we live, it's really hard to make a difference as an individual, just because we have communities where the grocery store is not within bikeable or walking distance. And that has to change too, the planned communities. But in the immediate time, to me, the most important thing is to educate yourself and participate in the conversation, contact your elected officials, and that's a great first step. And you should be extremely content if you're capable of doing that. And there are other things you can Google them. Some of them I read, I go, I'm not going to do that. Like take a cold shower. but maybe you want to. But if you Google, there's a litany of things you can do as an individual. Oh, well, as a matter of fact, your water heater temperature, right? If you have to add cold water to your hot water in order to make it tolerable, then you're wasting energy. The hot water coming out of that side only should be whatever temperature you want. Otherwise, that hot water heater is just heating the water with electricity or natural gas. So there's many other things that you probably never thought about that you can go online, say, how can I make a difference? And you'll find that those are practical. There's no reason to dilute your hot water with cold water, right? So that's a great question.
Okay, and that's all the questions in the chat online. If you're online and you have more questions, please put them in the chat and we'll monitor that for another couple of minutes. Does anyone else in the room have any questions? Come on up.
Okay, Randy, and I know that that we did several mapping projects in the past, looking at several of the scenarios that you talked about, the various levels of sea level rise. Is there a site on, do you know of a website where people could find those maps to take a look at, see how it might exactly affect them in their own home or property?
So yes, if you, I know Climate Central has one. If you just Google sea level rise visualization tool, and there's several of them from NOAA, I think has an EPA, and you can zoom into your community, and then you could slide. I guess this is a dashboard. I'm not trying to become my parents. I actually know that word. And you could slide the elevation to see how the area will be inundated. So sea level rise visualization tool, there are several of them. They're very user friendly. And you could picture a range of rises, which are the same ones that I mentioned here, the NOAA ones. So those ranges are not just random, they are based upon what we can anticipate. Yeah.
Basically 3 to 8 feet.
Yes, I don't remember that, but it may only go to 5 because people don't want to know anything more, but it is really interesting. And you can look at where you are. It doesn't have any time when that will occur. But if the conversation is, for example, I use elevations at the end of the century, you can imagine it's half of that or slightly less because it's accelerating. By 2050, we will have anywhere between 2 and 3 feet, or excuse me, 1 and 3 feet. And then 3 and 8 because it accelerates. But by 2050, there will be substantial impact of at least 1 foot of rise.
Yeah, come on up.
Just one more.
No, ask
Okay,
all you
so
want.
those of us here and those of us online tonight are interested in this subject, obviously, and concerned. How do we get this? As a society, as a community, how do we get more people interested in this? How do we depoliticize it and make it more interesting? And I'm not saying you should be Dr. Doom, but how do we get the word out?
So it's very unfortunate that it's been politicized, but so was asbestos, cigarette smoke, you name it. That's just how apparently we deal with these huge threats. I will say that when I channel surf news, all the major networks are routinely describing during their weather, and there's an anomalous behavior into climate change. And as you know, or don't, we've already had a tropical depression. This is not hurricane season, and the National Hurricane Center is preparing or just considering moving the hurricane date up 2 weeks. What do we do? Well, I think your question was like, again, kind of sort of, what do we do? And I really think it's conversation, and when you see things, you hear people talk about it, their denial, or when you're in a group and the discussion, you try to stay away from politics. This is not politics. This is resilience and sustain. It's survival for our communities here. So I would just say engage, engage, engage. And there is a ton of information. It doesn't take long to figure out what's BS and what's not. There are many, unfortunately, none coming to my head right now, but many websites that have detailed, really beautiful graphics. They have counters to standard arguments of denialism. But I'm happy to say, just based on the state of Florida, watching TV, the conversation has moved and we're moving in the right direction. I mean, that is encouraging. The question is, are we going to be able to move fast enough? But so I'm hopeful on that.
Come on up.
So I've got a question. Help me understand better the California coast raise of the water. You talked about the tectonic plates more than anything else. Are we thinking that as the San Andreas, et cetera, does whatever it does, the ground is sinking, the ocean floor is rising? What is causing the California coast rise?
So let me just do this graphically. So this is the Pacific Ocean and the ocean crust, and here's the edge of the US continent. And the Pacific Ocean crust is going under, right?
Okay, yes.
And as it melts, it comes up and produces volcanoes and stuff. It's like Mount St. Helens. But as it goes down, it buckles.
Okay.
Hence the Sierra, the coast, all those mountains are buckling from the collision. And if you walk along to California, in fact, that whole coast, and you're standing and you're looking at the beautiful coastal bluffs, that's all ocean sediment. It used to be underwater, but it was pushed up over the last 100,000 years or more.
Okay.
So if you're standing on the last 100,000 years, to you, sea level's rising, but it's not. It's the land. Sea level's falling. It's the land. So as I mentioned in the different mechanisms, there's the global contribution of melting continental ice, thermal, and then locally, the signal, the tide gauges that you have will vary depending on all those things. Some of which are regional, like the entire West Coast or the Gulf of Mexico, some of which might be more local. So it's complicated, but we already know all of this stuff. And we know what the causes are, and then and that's the first step in planning is, what are the measurements and where are they coming from?
Thank you.
Okay, so we don't have any more questions in the chat, no more questions in the room. So thank you so much for your presentation. I think we all learned a lot. I hope the folks at home learned a lot as well. As a reminder, we do have 2 sustainability information sessions coming up in the month of June. I believe it's on the 23rd. We'll be hearing from Dr. Bonnie Wells with IFAS regarding fertilizers and fortifying your lawn. And then on the 30th of June, we'll be hearing from Florida Power and Light about their Solar Together program. So with that, I think that wraps everything up. Thank you all for joining.
Thanks for the invitation. Thanks for attending and attending.
Thank you, sir.
Yeah. Oh.
But basically, your motion surface, I would say it's consistent.
No, not, I didn't get into that.
Yeah.
So if you look at the surface of the ocean, it is not flat.
Oh, no.
And that's like from wind, but it's also from density of
Gulf of Mexico.
Yeah.
There's a whole bunch of factors.
and of the continent. So stuff gets pulled, and the relief of the ocean surface is tens of meters, like 30 or 40 feet, easy. I mean, in the Gulf Stream, there's literally a slope.
Yeah.
But that's all sort of reconciled with your mean sea level, and you get various oscillations over decades, or so on and so forth in there. But